Okay, so for this video, we're going to work out some bolt shear force problems. So I want you to make sure that you've reviewed one of the videos on how to work through these bolt shear force calculations to determine the max shear force, or which bolt will break first is the question that we're asking for these problems. So that way we can design the bolts to be strong enough so that even the bolt that is going to experience the maximum shear force will not break due to that force, okay? And normally with this, you would want to add in a factor of safety. So check the factor of safety for whatever your application of this is, and you would just multiply the force that's being applied by, let's say, 1.2 if we have a 1.2 factor of safety. So that way, if we happen to get this force plus another 20% of that force added on top of that, then we would still have bolts that are designed to withstand that. So without further ado, let's get into working these problems. So I'm assuming that you're working this out, and you'll pause the video before I show you the solution. Alright, let's start with the simple one. We have two bolts, bolt number 1 and bolt number 2, and their centroid is there. They're each a distance d away from that, small letter d. And then we have F here acting at a distance large d away, or capital D away, and then this creates kind of a moment force, and then these bolts must react to that, so there will be a moment force going about that direction from those bolts to react to this moment force from over here. And then we also have a vertical component, which is going to go in the opposite direction. Since this is going down, we're going to need these bolts to push up in reactions, so that way this beam doesn't start moving this way. Okay? So I'm going to go ahead and show you those equations, and then you can see that the magnitudes of those are both shown, and then to determine which one will fail first due to having the maximum shear force out of the two, we're going to add the components of the shown in green, the force, vertical force reaction forces on each bolt, and then the moment component shown in blue, okay, which is perpendicular to this centroid D. So for this, it goes in that direction, because if we want a reaction moment that goes like this, in this direction, to react to this force going in this direction, we have to have this moment going in this direction. Alright, so we add those two force vectors together, and we end up with bolt 2, you end up with the overall force, shear force that is smaller, and then on bolt 1 we end up with a larger shear force. So we know that bolt 1 is more likely to break in shear than bolt 1, or stated in other words and probably more accurate, the maximum shear force is going to be seen by bolt 1, and bolt 2 is going to see a lesser shear force. Alright, let's do this problem. Alright, I'm going to pause and let you work through this real quick. Okay, I'm assuming you'll pause the video and finish working through it, so I'll show you the solution. So here we have the force components, similar to the equation shown above. I'm just going to show you the solution. And similarly, we have the moment components, and then we are adding those vectors together, and we get that these bolts over here have an overall lesser shear force than these bolts on the right, and these have the same magnitude shear force So we would say that both of these are the bolts with the maximum shear force, and they're going to break first in shear. Okay, so, whoops, sorry about that. So now we're going to look at this last problem, and I've maintained that we're using 4 bolts. We're just rotating them here so that we have 2 bolts and then 1 and 1, and assume it's the same distance apart, and solve the problem. And now I'm going to show you the solution. Okay, so we have the force components and then the moment components, and you might say, oh, those look exactly the same as the previous problem that we did, and you would be correct. However, these moment components are now going to end up subtracting on this side, and then these two come out to be the same length for the max for the shear force. And then here, when you add those force vectors, you end up with this bolt on the right side having the maximum shear force experience. So you would want to design so that this bolt can experience this max shear force and not break. So you would either select a bolt accordingly, or design for a different bolt that could withstand that amount of shear force. And remember to keep in mind your factor of safety, so you might want to multiply that force by 1.2 if you have a 1.2 factor of safety, and then design for a bolt that can handle that larger force, that maximum shear force. And some people use a factor of safety of 4, so 4 times that maximum shear force, and some people use a factor of safety of 1.2. It really just depends on the application, so check what that would be in the standards that you're using, or in the industry that you work in, what is common to use for that factor of safety, especially if this is a very critical component. All right, thanks for joining.